Hello, everyone, again. Welcome to today's session on Quality 4.0, right? So I'll try to kind of like keep it more interactive and then like try to kind of like address most of the questions with respect to the kind of, the time that we have. And I'll try to kind of like detail out as much as possible wherever it's more relevant. So we'll start with my introduction. So my name is Ram, uh, Chief Data Strategist at Data Culture of Setting Technologies. I have a couple of decades of experience in data and the fields around that, and responsible for data transformation, worked with multiple companies in the past or multiple clients in the past. Have been through the journey for implementing and monitoring the data transformation across the industries. Something that's more about me, right? So we will set some sort of context towards like what we are about to see today, right? So what is there in store for today's session? So we'll start by understanding the evolution of quality management. We'll trace the journey from the traditional inspection-based methods to the current data-driven intelligence systems that we have, right? And next, we'll start by exploring the concept of Quality 4.0, why it is more important, what are the new technologies that can be part of it, even how a KPI can actually evolve from Quality 1.0 to 4.0, right? Post that, like we will try to learn how to harness the data for proactive quality management, leveraging some of the real time insights for predictive and prescriptive strategies also. Finally, we will discover the kind of roadmap to implement the Quality 4.0 in any industry or in your organization specifically. So we will start with the evolution of quality control. So what does even Quality 4.0, what is even Quality 1.0 per se, right? Where did it started and how we are right now today? Just a quick recap of how things have actually shaped up in the past century. In the early 1900s, thinking with the industry 1.0, the quality control or quality 1.0 came into picture. It was more manual, more reactive. People used to manually collect the data from each of the post production, and then like we'll calculate, say, what is the number of defects that's there, or what really happened with that particular production is what really happened. Come 1940s, introduction of statistical process control and industrial revolution, industry 2.0 came in, and then that's where quality 2.0 started. Introduction of statistical methods came into picture, um, allowing the manufacturers to monitor and control process during production. Basically, this reduced some of the defects and it improves quality a bit more, but not that particular, at the great level. During industry 3.0, so that's in early 1970s, introduction of computers came into picture, total quality management came into picture, introduction of Six Sigma and continuous improvement methodologies came into picture. This actually sets high quality standards, right? But it's still not at that particular level as what we actually wanted, but it didn't have the kind of, the real-time monitoring, though with the usage of computers also. Quality 4.0 came into picture in the early 2010s, aligned with Industry 4.0, right? It started integrating artificial intelligence. It started integrating IoT devices. Big data analytics came into picture. It provided the way for us to proactively manage the quality, and it paved the way for predictive and prescriptive quality management systems, right? So it's not something that's there as new, but it's all about like say implementation of technologies by not overruling any traditional quality management systems, right? It's leveraging more technologies is what really happened. So what really is Quality 4.0? So Quality 4.0 is something that's applying Industry 4.0 techniques to enhance quality management, shifting from reactive to predictive control. What are the real benefits that comes out of this is that like say you can have enhance product quality. It can really bring in operational efficiency. It can reduce the wastage. It can reduce the amount of rework that we need to do by optimizing the production processes. It can bring in cost savings. It can reduce the kind of scrap and warranty cost. That's reducing the production cost in itself. Uh, It can give a competitive edge across the customers among your the competitive field. It can bring in regulatory compliance into picture, and those are the real benefits which the industries have started observing today. How does it really compare between the traditional qualities? Some sort of recap between from the past couple of slides that we actually saw. The most important point that we need to take a look at is the scope of the quality control, right? Whereas in the traditional quality control, the scope really focused in terms of product centric, because we were more and more reactive, right? So we took a look at one of the product, and then we took a look at how do we really control the quality over there. But Quality 4.0 really brought in the holistic approach of quality control. So it's not just something that focuses on your product, but it can focus on your product as well as your process as well as the system. The holistic quality control means you have more and more control across your process, right? Moving on, what are the key drivers that is something that's driving or which makes companies to adopt Quality 4.0? The increasing complexity of the manufacturing processes, right? Products and processes have become more and more complex, right? We are looking at more and more advanced technologies that is being brought as part of the production scenarios. So which means the traditional methods in terms of controlling that particular quality which is being produced by modern mechanisms won't actually withstand. Second, in terms of today's market, customers demand higher quality products. They need more transparency with respect to the production process, right? They just don't want to take a look at how a product is being how the product is coming into the market. They want to take a look at how the product is being produced also, right? Which means we need to take a look at how are we manufacturing, what sort of quality processes and parameters that we are actually ensuring. A lot of compliance came into picture. A lot of organizations have put some sort of quality control parameters and process parameters over there. Say in pharmaceuticals, FDA came into picture. A lot of audits came into picture. So which all drives the need for bringing automated real-time solutions to monitor our quality, right? Let's pause for a moment and consider the quote. Embracing quality 4.0 is not just an upgrade. It's a paradigm shift in how we approach quality in manufacturing. This statement encapsulates the transformative nature of Quality 4.0. It's not merely about adding new technologies to existing processes as we saw earlier. Instead, it represents a fundamental change in our approach to quality management. It requires us to rethink our strategies, retool our processes, and reshape our organization culture to fully leverage the power of data, and also to adopt advanced technologies and quality control. As we move forward in our discussion, keep this idea in mind. It will help you to understand the depth of the change that Quality 4.0 can bring in, and what potential it actually holds. Though we are actually talking about the potential of Quality 4.0, what really is stopping? What are the key challenges that is actually impacting adopting Quality 4.0? Is that recently a study by BCG revealed that only 14% of the people who responded to their survey believed that their individuals across their organizations understood their roles in achieving quality goals. And in fact, the same study revealed only around 20% of the companies have begun the planning for integration, which means they're at the very, very early stages of their quality control integration process, right? American Standard Society for Quality, along with LNS Research, they did a survey, and the survey revealed only 39% of the leaders believe that lack of skills and training as the significant challenge in adopting Quality 4.0, which means which brings in the need for skills and training, right? A quick recap of what are the key challenges to kind of to conclude what we saw as kind of in a challenge. Data integration is a challenge because we are talking about data that's coming in from various sources. We will see that what are the data sources that's actually required for Quality 4.0. When we are talking about multiple data sources, multiple departments being there, which means it calls in additional technology infrastructure requirement, right? So we need a bit more investment on that particular front, or we will be talking about how do we automate the data collection process, which means like bringing in IoT devices, analytical platforms integrations. There are like multiple things that we will be talking about in terms of technology and the data integration front. Which, when we are talking about multiple technology, which means like the need for the skill gap and training, obviously, right? The people who are within the organization, they need to upscale in terms of how are we going to take a look at it. And it's a cultural shift, right? Many people at many organizations, we always face a change, right? When we talk about quality 4.0, or when we talk about analytics, the first and foremost question that we get from the organization is that, like, say, I've always done things by this, right? It's a very, very dangerous phase in English currently. There is a need for shift, right? We were talking about multiple current technologies that's coming into picture, which means like you need to have a transformation culturally. We need to take a look at like how things happens, right? So all these are key challenges. Overcoming this is very, very key in terms of understanding this, right? Uh, it's not that simple, but I may not say that like it's not something that's impossible as well, right? It needs a bit of a shift in terms of mind, the cultural thought process of each and every personnel involved in the process. Talking about quality 4.0 again, what are the core components we did spoke about in terms of the key challenges? So bringing that out over here, data and analytics plays a very key part in bringing out quality 4.0. Connectivity is very important because like we are talking about automation, automated data collection processes. We need to bring in advanced technologies. AI, ML is going to be the key for it. Digital twins, blockchain analytics. There are like multiple factors that comes into it as part of it. Not everything is mandatory, but it depends on the scenario, right? How big the organization is, how complex the current manufacturing process is. That brings in the need for additional advanced technologies into it, right? Automation and scalability. Again, like your organization will be looking at in terms of scaling through the capabilities, scaling through the process. Tomorrow we might be adding more products into picture. Tomorrow we might be adding more and more machineries into picture, bringing in additional regulations into picture, which means the system has to be more and more scalable. Going back to data and analytics, which is the most key component of quality 4.0. In fact, like I can say that like it's the heart of quality 4.0. We are talking about data that's been collected from multiple sources, and which means like you need to have automated methods of collecting. So there are like various data collection methods that comes into picture. When there are multiple data sources, obviously the integration and the data flows has to be managed so that like you get a real time analytics come into picture. We'll see that in detail as we move forward through the through our case study. What are the various data sources that we are actually talking about? Just some of it, which is considered as part of the current quality control processes, right? So we're not talking about one department, one data source. We are talking about multiple departments and multiple data sources that's coming from each of those departments, right? Each department generates critical data, and integration of this data across department is very, very essential for real-time monitoring and to do a proactive quality management scenario, right? What is the other benefit is that like it identify the correlations. It can help you to identify the correlation between different factors that can affect the quality, which comes from different departments. So it's not something that's one. It can enable a holistic approach in terms of your quality management. By breaking down the data silos and creating a unified view of quality related information, organizations can make very informed decisions and respond more quickly to quality issues, basically, right? So a very quick understanding in terms of how do we, centralize the data, how a typical data architecture might actually look like when we go for quality 4.0, right? We are talking about multiple data sources. We are talking about, the data that's coming from different departments, which mandates a need for integrating all the data together. So we might be taking a look at, like, say, a data centralization layer or a layer where we can transform and standardize and normalize the data, right? Once that's done, you will have a kind of a data warehouse kind of a scenario from where we can actually move into the consumption layer or where we do our analytics, right? So once this is done, what does it really enable, right? So how does it really help? Take a look at this particular KPI chart over here, right? So different sort of KPIs that is available in during each of those stages of quality, right? One department and manual collection of data enable answering a very simple question of, say, for example, how many defective products are we currently producing, right? So what is the total number of defects out of, say, million products or say 1,000 products that we have? Use a sampling technique, right? And then like we can actually collect the defects across it. I take a sample of 10 products, and then out of the 10, 2 is defective. So possibly my defect rate is around 20%, right? That's what really happened in quality 1.0. Quality for 2.0, we can really add a few more of those KPIs based on the statistical models that's over there, right? So we can take a look at like how consistent is our production quality. It can really bring in your customer compliance and customer metrics over there and really answer like, uh, how good is my customer satisfaction? Is my customer really satisfied with my products? Quality 3.0 broaden the scenario or enabled us to answer like, how can we even optimize the quality management system, right? But the 4.0 introduction of IoT and AI really brought in, us ability to answer how can we predict and prevent the quality issues even before they occur, right? Now, consider for our case study, I'm going to take a very interesting question, which is more common across, the manufacturing scenario, right? It's a very common paradox in manufacturing. Why my customer satisfaction is low, though my production cost is very high, right? The first thought process over here is that like, let's not consider high production cost is something that's directly proportional to high quality, right? It doesn't necessarily mandate it. This question often arises when companies focus on increasing production or say implementing costly quality control measures without truly understanding the root cause of the quality issues. A low customer satisfaction could be down to various factors. Okay, it could be down to poor quality, it could be down to high product cost, or it could be down to say a poor customer support scenario, right? But how does these two correlate, production cost as well as customer satisfaction? Then we need to understand the KPI defect rate, right? Defect rate, as we saw earlier, it is the percentage of defective units in relation to your total number of units that's produced, right? A very simple metric. It needs your production log. That's the only data source that you actually require for us to understand what is my defect rate. This data in Quality 4.0, it's really collected through real-time IoT, right? So each and every machines or each and every production unit that we have IoT devices placed over there, and which can generate transfer the data in terms of how much of unit is produced and how many defective pieces are there using your defect tracking system, right? It's very crucial. It directly impacts your customer satisfaction. It directly impacts your production cost and your overall efficiency also, right? But you might have a question. Now, defect rate is something that's there available during quality 1.0 as our earlier the KPI table suggested. How does it really matter in quality 4.0? Or what is really quality 4.0 answers is that as the stages of quality evolve, the way how a metric or a particular KPI is being tracked and calculated also is enhanced, right? It's more and more effective currently. A quick snapshot, quality 1.0, you might be able to answer what is the percentage, but 4.0, you will have the ability to answer how do I prevent it. Let's see how. Okay, that's the real case that we have. Now, how do we calculate the defect rate analysis? As I said, total number of defects against the total units produced. A very simple trend shows that my historical average is around say 5.2%, right? I'm producing around 5 defective pieces for every 100 units that's produced, which is again across industrial standard. That's the same thing. Industrial standard is around 95% across most of the industries, for which I'm still good, right? But what is my real concern is that I have certain spikes and it's not very consistent. My defect rate is very, very inconsistent. It's very unstable, right? What could be the really factor? What could be the real factors? Which means we need to have a need to deep dive into understanding what are the root causes that is affecting my spikes, or what is affecting my inconsistency in my defect rate. For that to be done, we need data to come in from various other departments also. right? This mandates the move from descriptive to diagnostic analysis to understand what is causing the defect rate to fluctuate. On a deep dive analysis, first we did with a Pareto on a defect cause. We take a look at what is the factor that is affecting the most number of defects, right? So if you take a look at the first two bars, raw material and quality, the machine malfunction, right? That really contributes about 80% of the defects. So what could be the recommendation? Strengthen the raw material inspections, improve the preventive maintenance schedules for machinery, right? So don't let your machine to malfunction while it is in production. Do a preventive control of it, right? For which you need the supplier quality data, you need production incident reports. So there are like additional data sources that is actually required for us to understand this, right? Moving on to correlation to understand what are the various process parameters over there. We can take a, when we take a look at say temperature, pressure, humidity, machine speed kind of, scenarios, and then we try to take a look at the correlation. Humidity and machine speed have a bit more susceptible to or more contributing factors to increase defect rates, right? So you need to have a humidity control mechanism on the sensitive areas. You need to optimize the machine speed, possibly, compromising your throughput, but not compromising your quality. That's what could be done in order to improve your defects. I mean, improve your defect rate. So as to reduce your defects and improve your quality. Also, we did an additional, analysis in terms of taking a look at like, is my defect rate really affected by the type of shifts, right? I have three different shifts over here and possibly taking a look at the defect rates across each shift. Shift B consistently has higher number of, defects over there. So what could be the real reason? There could be, people who are, not trained well properly. Possibly there is a need for optimizing your resources across the shift. Put in additional training for the shift B operators. Ensure the kind of consistency that's over there. So this actually needs a bit more information. Say the previous correlation needs information in the data source from your environmental sensors, your defect tracking systems from various other sources also. Whereas your shift information comes from your shift logs, your operator logs, and possibly your training logs also to understand why that's happening, right? Now, this can really help me to understand why my defect rate is fluctuating, but still it doesn't actually answer, or it's still not at the stage where we can predict it, right? So what we need to do is that like we need to move forward. We have understood the root cause. Now I have a proper platform for me to kind of like lay down and say that, okay, I understood my problem. I can rectify and resolve it. I can proactively work on it. So I can take a look at like what's going to come up next, right? The next step is to anticipate future defect rates and proactively manage and prevent my quality issues, right? We need to leverage the historical data and we need to bring in algorithms. We need to bring in, say something like say an AIML scenario to kind of like understand this. How do we do it? We implemented an algorithm. So currently in this particular scenario, ARIMA was actually being used. There are like multiple forecasting methods that's there available in the current scenario, right? So one of it is ARIMA. It actually uses moving average to understand what is going to be my defect rate over the period of time, right? It can showcase a stable trend close to the historical average. That's what we will be able to get, right? This stability allows quality control to remain more and more proactive without expecting immediate significant changes, right? But it's still not there, right? This forecast is a powerful tool, but it's still not something that's set on stone, right? It should be regularly updated with new data so that like your forecast keeps on getting updated, your model gets more and more accurate, and then like with that like you will be able to get some real-time monitoring. But also that's not something that's 100% there also, right? We need to take a look at my historical, say for example, in this particular scenario, my historical defect rate is still at the industrial average. How do I further bring it down? Is there a possibility for me to kind of like do it? it mandates or it creates the need for a prescriptive solution, right? We need to do some sort of prescriptions. We need to do some sort of proactive control so that I can further bring my historical, future forecast to come down. So whereas your predictive analytics anticipates to the future, but quality 4.0 can help you to further do it with prescriptive, right? The goal here is not just to understand the forecast, but to determine the specific actions that can reduce the defect rates in the future, right? There are like various methods to do a prescriptive insights. In this particular scenario, we use something called as a scenario simulation. So you can actually take a look at it. There are like a couple of lines for the future. One is red and one is green. The green one is what is after the prescriptive action. So you can actually see there is about say 10% improvement in my defect rate. Over the period of time, it's not that great, but it's huge in terms of the manufacturing context, right? It compares two scenarios in this particular scenario, and it provides some sort of prescriptions. It can controlling your machine speed as we how we identified in the historical trend. In our diagnostic analysis, beg your pardon. So in diagnostic analytics, we identified humidity and machine speed as the common causes. Shift B is the shift B is one of the other reason, and also the machine malfunction needs for preventive maintenance. By implementing all these things, we simulated a scenario to take a look at like how my defect rate will actually perform, and that's where we got a 10% improvements. That could be the most optimized defect rate that we might be getting, right? I'll take a pause over here, just kind of like for you to kind of like gather your thoughts around this. And a very quick sample in terms of how a KPI such as my first time quality might actually, work with quality 4.0. Just a quick snapshot, though not much detail over here. FTQ rate over the period of time. First to start with, FTQ is a key metric. It is used to identify the percentage of product or services that meets the quality standards on the very first instance. Okay, a very key metric that is actually come into picture in the very recent times. FTQ rate, the first trend showcases there is a bit of a fluctuation, but it's still not up there. What could be the causes? Defect types that's contributing to the FTQ failure. What are the root causes? And then like moving on from there, forecast. And there is a short prescriptive for FTQ improvement also, right? So that's there in picture, right? So we identified how well a projected improvement, projected FTQ improvement can happen with respect to various factors, okay? And also we tried to do a bit of an analysis in terms of what is the amount of cost or effort that's actually required to implement that particular prescription, right? So it's not something that's there, again, like say that like there is a thumb rule in terms of how do we do that, but it depends on scenario to scenario, it depends on various factors also. And based on that, we need to arrive at what is the algorithm that we need to use and what is the method that we need to use for our predictions and prescriptions. Said all these things, right? So we took a look at like how this particular KPI moves on, how quality 4.0 is actually helping, but how do we really do it? What is the kind of roadmap that is actually suggested for us to get through with this? This is how an assess roadmap will actually look like, right? It's a 7-step process that we call it. We need to start with assessment of the current stage, evaluate your existing quality management process, technologies, and your data infrastructure. And then the stage 2 is to define the quality 4.0 strategy, align your quality goals with your overall business objectives, and identify the key areas for the improvement. And based on that, define the strategy. Moving on from there, implement the necessary data collection methods, the storage infrastructure, and the processing systems, and have the setup ready. Once that's there, you can have your integration of your systems. You can connect your various data sources and systems to create a unified quality management platform. Once this is all there, once the systems is all integrated, then we can really go for deploying the analytical tools and AI models for your analytical insights. And it can pave your way for your predictive and prescriptive insights also. Then once this is all done, we were talking about the skill gap and the training. That's actually a key challenge in terms of implementation. So we need to have a process, or we need to have a step to include the training and the change management. Ensure your team has the skills to leverage new technologies and adapt to data-driven processes. Once this is all there, the process doesn't stop. We need to go for the continuous improvement. Regularly assess the effectiveness of the Quality 4.0 initiatives. Refine your approach based on your outcomes, right? It provides a structured approach in terms of implementing it, but you know, it's not something that's there again a thumb rule in terms of this is how exactly that we need to do it, but we need to tailor for each and every specific organization. It differs. There could be an additional step over there, but this is what, in a nutshell, how an implementation or a proper roadmap actually helps an organization to move and adopt 4.0, right? Take a pause over here.